Director and Chief Operating Officer of Confluence Resources Associates Limited. Mr. Olamide has made significant contributions to advancing geospatial solutions and drone technologies across various industries. His dedication to innovation is reflected in projects that integrate cutting-edge technology to deliver precise and actionable data. With a round of applause, please welcome Mr. Olamide Oye.
Thank you very much. Okay, yes, it's an honor to be here today. I'll be talking mainly about how you can apply everything we've been talking about here into your real life projects, because I understand that we are all professionals from different fields, from different backgrounds, and the advantage I actually have over what we've all been talking about is because I started from a planning background to surveying background to oil and gas systems and GIS in different fields, even in the agricultural field. So I've gotten to work in different projects. So in my line of work, I've met Tokwe in the line when he was coming up also, and Surveyor Chika too. He was one of my trainers when I was coming up as a surveyor, but I decided not to go into the surveying field because it's somewhat complicated. So it has come from different lines of sensors. And from how I've been looking at it, it keeps on improving over time. The LIDAR systems of last year is different from the LIDAR systems of this year. Even from what I heard from Surveyor Chika, that this even does automatic processing. When I heard that, I looked at it means this thing is upgrading again. Because even from the GIS, I think from the workshop that was done this year, it was said that AI is taking over. So there's a system that's like ChatGPT now, that is in the GIS world, that once you want to analyze data, you just type it, you just type it the same way you type into ChatGPT. So once you gather your data, once you want whatever you need from that data, just type it into the system, it will generate it, instead of the old system of click here, click here, click here. So things are changing over time, and I would really like to encourage everyone of us. Let us not restrict our knowledge to what we know or what we knew yesterday, because it's always good to grow with it. Or unless you want overtaking, because I don't want people to overtake me, so but overtaking is allowed. Yes. Okay, so in terrain mapping, your LIDAR system will give you detailed information about your terrain. And when we mean detailed information, to the point of your depth, to the least depth. And one thing about LIDAR, like let me just buttress some of the points that was raised by our previous speaker, Surveyor Chika. Beyond generating millions of points, it's just like your television, your old television. If we could remember the box TV of then, we could, when there is no signal and it's showing a blank screen, you see tiny pixels, tiny boxes when you look at it very carefully. Those tiny boxes makes a picture on your TV. The same thing is the same technology that applies to the LiDAR. So once these point clouds are tiny points, and each of these tiny points has its own property. And property in terms of texture, in terms of coordinates, the X and Y, and the elevation. So it's these points that will now give you what you need. Like for instance, if you have to take a LiDAR shot of this entire room, the edge of this camera standing here will have its own property. So if you even need only just the properties of this camera, it will give it to you. If you need the properties of maybe the pillar standing there, it will give it the height of the pillar, the width of the pillar, everything you need about that pillar. So that is what makes this very, very interesting. And that is why it combines everybody's interest into one. So beyond looking at terrain, if we look at in the agricultural sector, in even mapping crops, that is where we look at crop classification, because the color gradients for your data will help you classify your data and help you extract what you need. Because once you can classify it, you can then extract, okay, what is of this height? Because it now depends on your own understanding of your data. Because one thing about me is that I love data. Data is very sweet. Once you capture good data, it's very sweet. Because what you can achieve with that data has to do with your own mind and your own thinking. Because once you can think rightly and you say, okay, I need all the surfaces at this particular elevation. With that, you can extract and query that at this particular elevation, I need everything at that elevation. And if you need like for instance, if you need like the roof of a building, you can just say everything above a particular height. It will give you the entire data. And also in the urban planning field, it's with the point cloud data, it can give you the building heights. That's complete building heights of every building that has been captured within a particular area. So with the building heights, you can easily generate a map without even doing much. I know in the urban planning field, our ancient way of doing things is to carry our paper or our questionnaire and go to the site. We'll write building, okay, 1 floor, bungalow, 2-story. We'll write everything down. That's the old way of doing things. With just your drone and this sensor, it can capture every data you need. The only thing you just need to do in this case might probably be to update your data, because you need to do your land use, either commercial or so on. So you can just update the data. But when it comes to land cover, you can extract residential, that is the built-up area, from the vegetational area. So you can do land use classification with your LiDAR data. So beyond that, you can then do roof material classification because of the texture of the roof of the building. So you can now extract what type of building to what type of building. So with your data classification, you can do all that. So like I said earlier, it's now your own question. What question do you have for your data? I believe AI is taking us towards that line, whereby it has to do with your thinking. Once you have that thought that, okay, this is what I need for my data, once you just have that, you can query your data from so many things. And one of the good things about LiDAR data is that it has the ability of generating different data sets. Like it said, digital terrain models, that one will give you your terrain. Digital surface models, that one will give you all the surfaces that have been captured. And then you can generate your drainage flow map. That one will give you your directional flow for drainages. And you can analyze for watershed. Like I could remember a community that we had to resolve one of the issues that has been an issue to them for a very long time. Because they came together as a community and they said, with this drone, because it was one of them that just came up and said, with the drone, you should be able to tell us where to direct our drainage, because it's in Ikorodu, and you know Ikorodu, sometimes It's until government is interested, or like some people would say, it's until government has a girlfriend in that area, that's when they will do something. So in that area, nobody knows government, nobody knows anybody. So they came together and they said, with this drone, we should be able to solve our drainage problem, our flood problem. And funny enough, flying over that area, we realized that it was just, it was a watershed issue, because that area was more like an area collecting water from different places, and the water comes there to settle. And it's because people have developed in that area. So with that, having an overview of their community, they could see where the problem is coming from without even involving the government. So with your drone and LiDAR mapping, you can do all sorts of things and capture vast amount of data. So moving on, in the oil and gas sector, I've seen where LiDAR has been used to do an as-built survey of a platform, whereby after installing the entire platform, because when you do the initial engineering drawing, and the engineering drawing itself is different from how it has been built, the exact structure itself. So with the exact, with having the actual survey of the exact structure, you now have the correct coordinate system, you now have the correct measurements of what has been built. So with the LiDAR system, you can use it to generate the as-built survey of a route. The only thing I used to say is that some people look at it that, when you propose a system like this, when they see the money, they say, this thing is very expensive, but it saves you a lot of money, really. Because if you go through the old systems of deploying surveyors along that route, the surveyors would have taken beating. They would have chased some of them with cutlass. But when you have your drone, you have deployed your drone, you are carrying out your survey. Nobody, because there was a time in Ekiti State that we were carrying out a survey, and the hunters came to the upper later and they said they saw the thing, it was flying, that they shot at it, they were trying to shoot at it. They could not aim at it at 100 meters altitude. So, which means that, I was even laughing at the back that, it means that my drone, people cannot shoot. Because they were wasting their bullets, it's valuable to them. So, which means that with your drone, you can make it very easy to survey areas without actually deploying surveyors on that field. Just like you said, with your total station, your LiDAR can actually do better and give you more data to your use. Yes. So, beyond that, even for your geophysical survey and also for environmental management, for flood risk management, forestry management, mining, and also for your infrastructural development, it makes work very, very easy for you. And I just want everybody to just have a deep thought, like, in this field that I am in, how can these systems be very useful? And when you think about such a question, just think about it. What do you need to develop more on? Just like he said, that when you don't need to buy the drone, you don't need to buy the sensor, because truly the sensors are very expensive. If I ask him how much that sensor is, because I'm just saying it for the first time, it processes automatically 1 terabyte. Wow, that's good. So it's very expensive. So you don't need to raise the money to buy it. You can come up with the knowledge, like know about it. Propose it on a project. You don't even know the kind of project you will even propose it to. And once you propose it, at the end of the day, you'll be the project manager, you'll be the supervisor, or you will play a major role on that project and you'll learn more. And by the time you go out there and you talk about it, most especially even outside, maybe you have like an international project, and you talk about it, people will know that, wow, you've really done like a great project in your previous years. Like one of the projects that even, like say, raised some of my CV when I gathered profile and all that, was it's just like even flying drone within on land is actually very different when you fly offshore. It's completely different. Your orientation, compass, location management, everything is different. Because it's more like when you take off and you say return home, your return home is not return home again when you're offshore. Your boat has moved, your return home is on water. So things like that. So having this knowledge is enough to actually push you forward, push your career forward. So I'll just encourage every one of us, let us not limit ourselves to what we know, but learn more about everything, even beyond this space. Even there are AI systems that are supporting these systems at the moment. So if we learn about them, we will go far in our career. Thank you very much.
Okay. Good day, everyone. My name is Okoye Ajinla from the Department of Geography and Regional Planning, LASU. So, actually, at the moment, I have just three questions, in which my question goes as follows. The first question says, in the aspect of drones and remote sensing, we all know that according to the United Nations, remote sensing was defined as the sensing of the Earth's surface from space, actually with the use of properties of electromagnetic waves being emitted, reflected, and diffracted. Do you understand me? Actually, this remote sensing can be used for land management, property management, environmental protection, and every other stuff. So my question is, with this implementation of drones, can we actually, we know that in military movies or some specific types of drones, just like you have said, you said that there are some specific drones that can fly intercontinental. So now my aspect of question is that, are there some specific types of drones that can actually fly out of space into the atmosphere to get specific data? You know, we said there are different platforms of remote sensing. We have land platform, the ones that we actually man them on vehicles and stuff. Then we also have the area platforms, which are the drones that are flying. Then we also have the satellite platforms, which are the satellites in space. So now my question is, are there specific drones that can actually go into space to take specific data or specific information? So can I go on with the other questions? Okay. Yeah, so my second question would be, how, you haven't said how we are going to get the license of unmanned area vehicle from NCA. Like, how can we get our license, even if we are going to be piloting a drone? How can we get our license? Through the website or whatever thing we just need to know. So the third question goes like this. For global use of large geographic urban planning, which is preferable to use between LIDAR and radar system? I mean, for a geographic urban planning that is very large, a specific place that is more like a community or something, just like states and stuff, which is preferable to use, LIDAR or radar system?
Okay, so let me start from the very first question. That's the initial remote sensing method that we capture from the satellite. Actually, what even made even the UAV systems more popular and more useful is because they are more affordable and everybody can capture data at ease. Unlike when you say you want to use the satellite, so it's more expensive when you use the satellite. So now, when you now say if there's a drone that can go, when you go up there, you are seen as a terrorist when you get to a certain height. Because China tried that. There was this balloon that was flying everywhere. And they had to shut it down at some point because people wondered what was that. So having a drone up there is too far. If you have a satellite, it's easier to capture data. And that's what Google Earth tries to update us with. But even Google Earth is not as sharp enough as our drone data. So I think the second question, NCAA. Yeah, like you heard Mr. Topper, he said it's better you get FAA license, which is easier because it's international. But NCAA, on their policy and guidelines, they said go to their website and apply. Yes, you can go to their website and apply. It's more like you go, you apply. Any year they answer you. You
That is Nigeria for you.
follow up. Yes, yes. So, for better knowledge on either LIDAR systems or radar systems, I'll prefer Surveyor Chika to respond to that because it's my organic that field. Surveyor.
Yeah. Different level of electromagnetic sensor, but LIDAR is specifically light detection and ranging. So for radar, it could be infrared, it could be other sensor within that range. So that's the difference. So if your interest is in health of crop, you know that's a different sensor. So that near infrared sensor can be used. So and all those different sensors can be used on your drone. So your drone can carry multiple payload. So the most common payload is the RGB. You hope you know RGB is still part of the electromagnetic sensor. So the RGB is the visible light region. So that is a sensor, like the normal camera. All this camera they are using now is RGB. So the LiDAR is another sensor. Then radar is another sensor. So radar could be infrared, could be multispectral, also within it. Hope that answers it. So
Which one is very useful
for you want to see the buildings, you want to see how they look, it's RGB. If you have interest in land use, land cover, infrared will be used. If you have interest in soil condition, multispectral sensor can be used. So, but if it's a large expanse, you just want to see which area is building, which one is tree, then that is for RGB. But if you are interested in topographical information, topo, you're interested in the terrain, the accuracy of your terrain, then LiDAR is the best for that.
For public health, for example, is it really necessary, is it needed for public health and detection of the prevalence of disease or virus, like for example malaria in a particular environment or urban environment or rural environment?
Okay, so to respond to that, one of the data you capture for public health will be population and also what you do to arrive at your data before approaching the matter is that you carry out a lot of statistics. Because once the statistics is run, it means either you apply so much demand on the maybe vaccine that you need to apply to the area. So for LiDAR systems, what it can give you will probably be to get information on population, households. Like for instance, once you have a bungalow and you know that there's a particular amount of households that you can apply to that bungalow, or it's a flat building. So having building data, building information data can actually give you enough information to even use for your statistics without deploying much resources on the field. That's how you can apply these area systems into your data gathering.
How can drones be used to improve last mile delivery in supply chains, particularly in areas with limited infrastructure, using legal safe as a case study? And I'm assuming because I've been seeing some theoretical paper that they talk about it, drones can be used, but I've not been seeing a lot of implementation on that. As there be a way where we can do that?
Okay.
So, I think he's talking about how Amazon delivers packages. How do you implement it in places like Lagos?
Okay. I'll first respond to what I feel is talking about before I bring in delivery of packages. Okay, so first of all, from my knowledge of Lagos State has acquired, I think they have 2 aircrafts or so at the moment. I don't know if it's still functioning, because I realized that they have their own remote sensing thing to capture data. So at the moment they capture data of everything, buildings, roads, and the only thing will now be the carriage capacity. What amount of vehicles that are passing, that will now be determined by what data you are collecting. So that will now still deploy people to the field to capture that data. That's in your own field of transportation. Yes, so you still have to carry out that data of the carriage capacity, how many vehicles are passing, and all those things before you can now say you need to deploy a 2-lane or a 3-lane or a 4-lane road to pass that area. Or if there's no road at all, to now see how you can now divert other road networks to reach that area. And when it comes to delivering packages, there are drones with high payloads that they can carry heavy payloads. Like I could remember there's this drone, DJI Cat. It's a new drone that was released this year. The drone has this ability of lifting heavy loads, even as heavy as a generator. So it can lift it and deliver it to wherever you need it to be delivered to. So once it gets there, it will communicate with the receiver, and once the receiver signs the document, it drops the item at the spot. And funny enough, this drone I think is available in Nigeria now. So you can still purchase it as a business owner to get involved in such businesses. Yeah. Next question.
Thank you. Good afternoon. My name is Oluwatoki Babatunde. I also do processing of data.
Yes.
Okay. Now, does it also surpass in this application to other professions that LIDAR, aside from doing the processing, it can also give a profile of maybe a vegetative land or maybe a built-up environment? Can you also go to the essence and do a profile?
Yes. Let me answer it this way. One thing you can do with your LiDAR is that once you capture the data, you have your data, and then you can carry out a classification of data, because there are different types of data there. So once you extract your data and you carry out a classification, you can then extract what you need. Like for instance, if you have a cropland area, and you use a sensor that can process NDVI. NDVI is a normalized vegetational index. Normalized vegetational index. So what it will do is that it will then classify the healthy crops from the unhealthy ones. It will give them different colors. So with that, you can now create a polygon to extract the data of that area, even with the coordinates, and then deploy people to that area or deploy your drone fertilizers to that area. So that's how you can then generate and use the process data for your own consumption. Yes. Question. Okay, we have two more questions.
From your LIDAR application, I can see seismic survey and land degradation. So I would like to know what, if LIDAR application can be used in deformation survey, how it can be applied.
Yes, it can be applied in information survey, but I guess he has more experience on that. Have you? Yes. Thank you very much.
Deformation could be for high-rise building, could be even for bridges. So what do you want to know in deformation study? It's the movements. And deformation survey is for what application? I just mentioned some building.
Sometimes, like now, we have land subsidies. Once you're extracting crude oil, you can have over time. After maybe year one, you have this land
Okay.
subsidy. And after about 5 years or 20 years,
Okay, okay.
so how can you?
Okay, subsidy. Okay, I get that point. So, like I said, when you are interested in studying the topography, LIDAR is the best. So, and you know, deformation study comes with trend over a period of time. So it means to have that data, you need to study it over a period of time. LIDAR will give you the highest level of accuracy for that particular time. But for you to appreciate the deformation, you need to do it over some period of time. You understand? And it will be much more accurate than using satellite imagery. Some people use satellite imagery for the same application. But if you use LIDAR, it will give you highest level of accuracy. Because what you want to see is how is the movement, how is the subsidence going, what's the change happening over that period of time. So I would recommend LIDAR. Though it will be a little bit more expensive than satellite imagery, but the level of accuracy you will get will be better.
are charts that aid navigation. They help air pilots in navigating their vessels. What I mean by vessels, their planes, even up down to your drone pilots. Without these sectional charts, you'll be able to navigate these drone pilots and vessels in the right direction. So these sectional charts, they show topographical features. And these features are important to them, such as what we have terrain elevations, we have ground features identified from altitude. Examples of these ground features, they have the rivers, dams, bridges, and buildings. And we also have ground features that are useful to the pilots themselves, such as the airports, the beacons, and our landmarks. So the chart shows information about airspace classes. We have type C, we have not exactly. So we have type C, we have type G, we have type E, we have type G. So we also have ground-based navigation aids, and we have radio frequencies, longitude and latitude, navigational waypoints, and navigational routes. So what we should always know is that our sectional charts always have a fixed scale, like all sectional charts. Always they use this particular scale to make our sectional charts, and this scale is 1:500,000. And sectional charts are always specific for a particular system. When you see a sectional chart, the name of the city is always like on top, and it is always for that specific city. Then we have, okay, airports having control towers are shown in blue, while all others are magenta. So let's see the next slide. So we can see here we have features, right? Then we have two colors. Some are in blue and some are in magenta. So what the previous slide says is that airport towers that have control towers, that means some have control towers and some do not have control towers. So those that have control towers are shown in blue, while the others are shown in magenta. So as you can see now, this legend now, in our maps, before you can understand a map, you need your legend. So what this legend does is that it shows you, it tells you what each features on the map represents. So we now have, so in your sectional chart, there are so many features. And without your legend, you won't be able to read that sectional chart. And we have this part, this first feature here, these two. The first feature, we have the round features, like two round features. We already know that the blue is representing those that have control towers, therefore that have control towers, while the other one is representing those that don't. So when you see these two round features, just know that they are airports that this represents surfaces that are not, let's say, tarred, other than hard surface runways that are not tarred, something like that. So we now have the other one, these two features, representing hard surface runways of 1,500 feet to 8,069 feet in length. Then you have this other one representing hard surface runways greater than 8,069 feet, or some multiple runways less than 8,069 feet. Then when we see this, a circle with R restriction on it. We have the private airports. Then when we see the double ring, we have the military airport. So as you can see, that is just what was explained earlier. The airports with blue color, the ones with blue colors has control tower, while the ones underneath with magenta color has no control tower. So moving on. So remember, in our first slide, we talked about airspaces, we talked about frequency, we talked about waypoint, we talked about many other things. What we should also note are the obstructions. So these obstructions and terrains are very, very important. We need to understand them while planning our flights. So this sectional chart, at the end of this, towards the end of this slide, I will show you the sectional chart. So we will see that sectional charts also represent congested areas. And these areas are always shaded yellow for recognition at night. So for them to be able to see this feature both in the day and night, they use a specific color to represent congested areas, and that is color yellow, shaded yellow. So we also have shaded reliefs, cities, towns, and drainage. So now underneath here, these are obstructions you can see on the sectional chart. And these are control towers, lighthouses. So when we see this long lighthouse, it is representing 1,000 feet and higher AGL. AGL means above ground level. Then when we see the one underneath, this one that looks short, that is above 200 feet and below 1,000. So we can see the range. The first one is 1,000 and above. The second one is 200 to 1,000 feet AGL, that's above ground level. So the next one, okay, in urban areas, you can see in urban areas we have above 299 feet above ground level. So moving on, we have this. When we see this symbol above the lighthouse, you can see the first one does not have that symbol. What it represents is that it represents obstruction with high intensity light, and they operate per time. This sign, high intensity light, that looks like a light. High intensity light, and it also represents whether the airport operates per time or not. So the next one we'll be talking about are the airspaces. I made mention of these classes, airspaces. So what this airspace means is that it's the portion of the atmosphere controlled by a country above its territory including its territorial waters. So what this means is like the map of Nigeria now. You know, we have 36 states in Nigeria, right? So the atmosphere above each 36 states in Nigeria are the airspaces. So it also includes the territorial waters of Nigeria. So we can see that we have the class B airspace, we have the class C airspace, we have the class D, we have the class E, and we have, okay, let's do that for now. So the class E airspace represented by a very thick line, shaded blue. The class C airspace, magenta, a very thick line, shaded magenta. Then we have the class D, or like a dashed line, shaded blue. Then the class E, a dashed line, shaded magenta. So when we see this, the next one, when we see this symbol, a number in between a, should I say, dashed box? I don't know if that's the right way to say, but when we see this symbol with a number in it, that is the ceiling. The ceiling is just like, you know, in a building, we have the ceiling. The ceiling is like the highest part in the building. How the floor, okay, we have the ceiling and the floor. So the floor is like the lowest part. So when we see this value, 40 here is not just 40. In your sectional chart, when you see numbers like this, their true meaning is understood when you multiply these numbers by 100. So that means this 40 is not just 40, it's 40 times 100. 40 times 100. So the next thing we'll be talking about is topographic information. So we have the road markers, the roads. So the roads are the line, while the road markers are those symbols on the roads. Then we have the railroad, this very straight line with some breaks in it. Then we have the power transmission lines, as in the aerial cable, the mountain pass, the landscape feature. So the landmark feature, landmark schools, factory, church, mosques, and so on. Then we have tank water, oil or gas, then the round one. Please let's take note of this. If the landmark is like a square, that is shaded. The tank water is a circle that is shaded. The oil well is like a ring. Then the mine of having mining instruments or equipment. So the next one we have is Air Force data. Okay. So remember I talked about airspaces. So each airspaces, the airspaces represents what the atmosphere above a country. So for each airspaces and airports, they have their data. And this data is not just a set of because 21 areas. Okay, something I forgot to point. Remember, the first question said it was 25 area 7. Because 25 area 7. So we can see these numbers 1, 2, 3, 4, 5, 6, 7, 8. A solid 7. So we are talking about, the question says, for you to locate the exact location, they will tell you the area where that location is located. So what you just need to do, the first thing you need to do in reading your sectional chart is to locate that area. So you can, anything you're now looking for will be found within that area. You understand? So the next thing now, okay, so the next question says, we got 21 areas. So let me locate that. Because 21 areas. Remember, this is because 25, so I have to go. This is 24. This is 23. This is 22. And this is 21. So the question says, because 21 areas, what is the CTAF frequency at Garrison DO5? Because 21 areas. So you can see the pointer, that's area 2. So what is the CTAF frequency at Garrison DO5? So let's search. Here is carrying VO5. If we say where? Yes, that's it. So we can see that, I don't know, this carries VO5 and the mix of figures and alphabets underneath it. That is what I explained in the previous slide. So now the question is, which one of those numbers represents your city AM frequency? Common traffic advisory frequency. Which one of them represents your city AM frequency? So let's take note. Is there anything familiar here from the question? So we have 193.7, 122.9, 118.675. Okay, so what's the answer? So that's the CTA frequency. And that still represents what? C. Sorry. What did you say? CTA. But what does it mean? What is it? Okay, so what does the color imply? Yes, sir. No controller, exactly. So the next question, the last question actually, so, okay. What type of airspace? Okay, figure 20, area 3. What type of airspace surrounds Elizabeth 60 regional ECG? Figure 20, area 3. This is 20. Because 20 area 3. So, Elizabeth, where are you? So, we said here on what airspace does it fall under? The airspace. Can you identify the airspace? Okay, so the airspace. Okay, we can see it is very simple. It's convenient. Right? That's like a guitar right? So the inner circle. Yes. Do we get it? That inner circle is your airspace. Yes. So look at it now. What does it? Just remember those lines we talked about. Remember those lines we talked about. So what does it come under? Are we sure? We want that again. Okay. What evidence? Let's go back.
I was lost. Are you guys to answer questions? Okay,
I guess everyone here is intending or already is a drone pilot. So if you were like me when I first started looking at sectional charts, I'm like, what the hell am I looking at?